Alright, so we will be discussing now another video, how to do the ray diagramming, or how to make ray diagrams in plane mirrors or smooth mirror. And we will be applying the law of reflections in this case. So let's begin. Let's have to draw first the principal axis or the optical axis. And then, of course, we need to draw a mirror. I will use another color for it. All right, so let's draw a plane mirror here at the middle. And then let's assume that the length of this mirror above and this mirror below equal at the center, or that pole. If we have an image here, image could be anything. Please remember, anything like ball or yourself. You look at the mirror and then you see object in the mirror, in a plane mirror to be specific. And in physics, we will be using arrow to represent the object. Please remember. And now let's do the first thing. Remember, we have the incident ray, and we do also have the reflected ray. And we will have the reflected ray as well. And always remember, you can only see the image once there will be a source of light or a luminous object that will interact to this object. Okay, and then the light will travel to the mirror and then go back or reflected towards your eyes. That's why you see the object or you see yourself in the mirror, because of the presence of light. Let's give credit to light because we can see things because of light. And now let's draw the incident ray. We will be using this black arrow to represent the uh, incident ray. The first thing you have to do, from the top of this object or your head, for example, if this is a person, you will go a ray interacting the mirror, and then what will gonna happen there? The next thing is reflection. Okay, and then our reflection, or I mean our reflected ray, will be represented by a blue arrow. So once the light interacted to this object here, it will travel to the mirror. That's the incident ray represented by the black arrow. And then afterwards, it will go back reflected at the same direction going there. It's parallel to our optical optical line. This line, that black line here. Okay? They are parallel, not meeting to each other. The next thing you will do, let's have the incident ray. We will use the black arrow, but this time you will have to go through the pole of the mirror, or this part here. Remember, we call it in my previous video as the pole, but it has another name in some reference, by the way. Now, we will use this. Okay, it's not perfect, but let's do it again. The incident ray from the tip going to this point here. That's the incident. And following the law of reflection, when we say law of reflection, if you could still recall, the angle of incident is equal to the angle of reflection. So if we have an angle here, it must be the same with our reflected ray. So we will be using now the blue arrow to represent the reflected ray. We will start at the pole and then reflected at some point. And we should always remember, according to the law, they must have the same angle here. So let's say 10 degrees, this will gonna be 10 degrees. Okay, so until this uh, ray here will meet the eyes of the person. And that's why you can see yourself in front of the mirror or any object in front of the mirror because of that. But it's not gonna happening that way, right? we need to know that this side here in the mirror, that's a real image will form. But then in this case, this is going to be called the virtual side of the mirror. And let's try to draw back our reflected rays because our brain will think that way. It will be tracing back the reflected ray. So let's have this one. This is going to be the first reflected ray, and we will trace it back going to the virtual side of the mirror. So we will be using the broken lines to represent the ray at the virtual part of the mirror. So again, the first ray, this one, let's trace it back. Okay, it's here, and then we will use the broken line to let us see where the image will be formed. So in plane mirrors, the image will be formed behind the mirrors or at the virtual part here. Now, the second reflected ray, we have it here. And then it will gonna have this broken line here. The point where these two intersect, that's our location of the image form. And in this case, it's gonna be like upright. We will have it this way. If you notice, same size because it makes sense because when you look at the mirror, you have the same, almost the same size or same size. You can see yourself like how you look like in the mirror. Same. So let's try to characterize the image being formed here. This is the image form, and if you notice, it's upright because the image is formed uh, above this optical line here or the principal axis. Okay, but if the image will form below, just like our next video, the object will gonna form like opposite or in inverse or inverted if the object will form here. But if the object will form above the optical line, our image will be like upright. Please remember that one. Let's describe now the image being formed at the virtual side of our mirror. And it's gonna be if you look at it, not magnified. When we say not magnified, it's not enlarged. So it's same size with your object here. It's going to be our object and it's going to be the image form. Aside from that, since it happened or it formed at the virtual side of the mirror, so we can say it's virtual, not real. And what else? The size, it's not real, but look at the orientation. Try to look at the orientation of the image form. It's upward, or in some other books, they will use the word erect or upright. The image form in plane mirrors has these characteristic: not magnified, same size with the object, virtual, not real, upright, erect, and or upward. It always formed behind a mirror. I hope you learned something from today's video. And yeah, if you like or it helps you at some point, don't forget to like, share, or even subscribe to this channel so that you will give me the motivation to do contents like this. Thank you so much.